Hello everyone. In today's session, we'll start with a new topic called matrix or matrices. What do we mean by a matrix? It is a rectangular array of symbols or numbers, arranged in rows and columns. Is known as matrix. For example, I can say capital A equal to, with the box brackets, I may write some numbers, some symbols, so this, whatever I have drawn, it has got two rows, 1 and 2, and then 3 columns. So we generally denote it by 2 by 3. We call it as 2 by 3, 2 rows by 3 rows. When we pronounce it as by, but when we write it, we write this cross, 2 cross 3, but we pronounce it as 2 by 3 matrix. So a general form of a matrix generally a matrix will be written like capital A is equal to, assuming that there are m rows and n columns. So I will write the elements as A11, A12, and so on, A1j, and so on, A1n. So there are n columns, first column, second column, and so on, jth column, and so on, nth column. Then A21. If you look into the suffix, it is like first one represents the position of row, second suffix represents the position of the column. So here it is second row, first column. This is first row, second column, first row, jth column, first row, nth column. So it is like that. A22 and so on, A2j, and so on, A2n. And so on. Let me write ith row, AI1, AI2, and so on, Aij, and so on, Ain, and so on. Let me write mth row, AM1, AM2, and so on, AMjth column, and so on, mth row, nth column. So as we had already seen, this particular matrix has got m rows and nth column, n columns. That means I can write this has got m rows and nth column. This m by n is called, let me write here, read as m by n is called order of matrix. Order of matrix. Here, a suffix ij denote the element of the matrix, in the ith row and jth column. Ith row and jth column. And it is applicable for all i's. I will say this symbol is for all I equal to 1, 2, and so on up to m. J is ranging from 1, 2, and so on up to n. So what are some of the learnings from a matrix? Number one, position of every element in the matrix has its significance. Means it is important. Every element is important in a matrix. Number two, a matrix has got no value. Matrix has no value and it is simply a representation, of data or any information. Either I can say data or some information. Then next point is number of rows of a matrix may not be equal to the number of columns. Right. Generally, any matrix is denoted by English capital alphabet. So I'll write that. A matrix is generally denoted by English capital alphabets and its elements by corresponding small alphabet followed by two suffixes. Plural of suffix, because there are two suffix here, two suffixes, right? What do you mean by this? If you look into this, this is capital A, all these elements are small a, and then followed by, let me take this as an example, followed by suffixes, two suffixes. First suffix represents the position of row position, second suffix represents column position. So followed by two suffixes. The first one denotes the elements elements, row position, and the second one, denotes its column position. The next, types of matrices. What are the different types of matrices? First one, horizontal matrix. If a matrix has less number of rows than its number of columns, I'll say that is M. Generally, M is denoted for number of rows. N is denoted for number of columns, which we had seen here in generalized expression of a matrix. M denotes rows, N denotes columns. So I say here that is M lesser than N. If a matrix has less number of rows than its number of columns, then it is said to be horizontal matrix. Example, I'll make a simple matrix. We know in this example, we have 2 rows and 4 columns. Of course, it looks like a horizontal matrix by look also. So the opposite of horizontal will be vertical matrix. That is our next type. If a matrix has more number of rows, or I can put it this way, instead of writing more, I put it as, if a matrix has less number of columns, than its number of rows, that is M larger than N, means number of rows are more than number of columns, then it is said to be vertical matrix. So again, example, let me write B, matrix B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here we have 4 rows, but 3 columns. So number of columns is lesser than the number of rows. Then the next one will be square matrix. A matrix is said to be square if it has got same number of rows as its columns. Matrix is said to be a square matrix if its number of rows is equal to number of columns. Means M is equal to N. For example, for that, let me write S equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has got 3 rows and 3 columns. And the fourth one is row matrix. A matrix is said to be a row matrix or row vector. Row matrix or row vector if it has only one row, irrespective of the number of columns, irrespective of number of columns. Example, I'll say R equal to 1, 2, 3. This has got only one row but 3 columns. Opposite of this is column matrix or column vector. A matrix is said to be a column matrix or column vector if it has only one column irrespective of number of rows. I should say irrespective of any number of columns, here also any number of rows. Let me call that matrix as C. 1, 2, 3. This has got 3 rows but 1 column. The next type is diagonal matrix. It is a square matrix. It is a square matrix wherein other than the principal diagonal, all the elements are zeros. All the elements are zeros. Means, let me write this like this. Here we have one word which came, principal diagonal. Let me just brief that. Let me just make a diagram here. Assuming that this is a square, right? We have two diagonals. One is this, and the other one is this. So the one which I had drawn from, let me write here A, B, C, D. Here AC is called principal diagonal. So whenever you come across with this word principal diagonal, they are actually talking about this as the principal diagonal. Principal diagonal. Okay, this is just for our understanding. Now let me give an example of a diagonal matrix. Maybe like that. A11, because it is situated in first row, first column. Here you may have A22 and so on. Let us say we have n rows and n columns, n rows and n columns. Here we have AN. Now all the other elements are zeros. This diagonal matrix can also be simply written as, D is equal to diag A11, A22, and so on, AN. So I can also write like this. I can draw the matrix also. Only thing is, other than the principal diagonal, all other elements should be zeros. That you call it as a diagonal matrix. Now, the next one is scalar matrix. It is a diagonal matrix wherein all the principal diagonal elements, are the same. Let me give an example. S equal to √3, 0, 0, 0, √3, 0, 0, 0, √3. This is a 3 by 3 matrix, 3 rows, 3 columns, but the principal diagonal elements, other than that, everything else is 0. So you call this as a scalar matrix, right? So I can also rewrite this as, I can take this root 3 outside, write it as 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. Actually speaking, when I took this square root of 3 outside, it means that the square root of 3 will be multiplied to each element. So root 3 into 1, you get this root 3. Root 3 into 0, you get 0. Root 3 into 0, you get 0. Means this can also be written like this. We will see what is this matrix in our next definition. Next definition is that only. It is called identity matrix. Identity matrix, also called as unit matrix. It is a scalar matrix. It is a scalar matrix. Scalar matrix means it will be like this. Suppose if it is of order 3 by 3, it is like this, but it is a scalar matrix wherein the scalar constant is unity. Means, example, I. Suppose if I am drawing an identity matrix of order 2 by 2, what we do is we simply write I2. I2 is nothing but 1, 0, 0, 1. You may notice the principal diagonal elements are unity, right? All the elements are 1 only. If I want to draw a matrix of 3 by 3 order, I call it as I3, 1, 0, 0, 0, 1, 0, 0, 0, 1. This is 3 by 3. So this can be simplified as root 3 into I3. A scalar matrix can be written as like this. Then the next type, null matrix. A matrix is said to be a null matrix if all the elements in it are zeros. It is also called as empty matrix or void matrix, VOID, void matrix. Generally, it is denoted by symbol O. So suppose if I want to write O 3 by 4, I write it as 3 rows and 4 columns with all the elements as zeros. So if I say O suffix 3 by 4, it means that it's a null matrix having 3 rows and 4 columns. All the elements are zeros. That is about null matrix. Right. So the next type is upper triangular matrix. Upper triangular matrix. A square matrix, is said to be upper triangular matrix if all the elements below, let me rub here, all the elements below its principal diagonal or zeros means, example, let me have a 4 by 4 matrix, 4 rows, 4 columns. Let me write some numbers, 1, 2, 3, 4. Then let me draw the principal diagonal, means 5. So 1, 2, 3, 4, 5. Let me write 6, 7, 8, 9, 10. So what I did, I simply made a principal diagonal and then filled up some numbers. And then here I have to write 0, 0, sorry. Yeah. 0, 0. So we may note here below the principal diagonal, all are zeros. So below the principal diagonal, all the elements are zeros. That's an example for a upper triangular matrix. Similarly, we have another one called lower triangular matrix. Lower triangular matrix. A square matrix is said to be lower triangular matrix if all the elements above its principal diagonal are zeros. Again, an example. I'm calling it as matrix L. Let me make a 3 by 3 only. Now, this is our principal diagonal. Just for our understanding, I just put a line over there. Above the principal diagonal, all the elements are zeros. So this is our lower triangular matrix. Right. Next, we will understand a definition of transpose of a matrix. Transpose of a matrix. Let capital A be a matrix. Then its transpose denoted by either we use A dash or we use A T, A transpose, denoted by A dash or A transpose, is obtained by interchanging row elements to columns and vice versa. Means column elements will become row elements. So, example, if A is equal to, let me put it as 1, 2, 3, 4, 5, 6. This has got 3 rows and 2 columns. Then A dash or A transpose will be 1, 3, 5, which is there in column, will become now row elements 1, 3, 5. And 2, 4, 6, which is in the second column, will become now second row. So 2, 4, 6. So order will completely become opposite. Instead of 3 by 2, it will become now 2 by 3. Means 2 rows and 3 columns. In general, if A is of order m by n, then A transpose will be of order n by m. Exactly, it will become opposite, the order. That is your definition of transpose. Now, based on the understanding of transpose, we have some more types of matrix. First one is called as symmetric matrix. Symmetric matrix. A square matrix is said to be symmetric if, or I should say, a square matrix capital A is said to be symmetric if A equal to A dash or A transpose. If both are same, means you can say it is symmetric. So what is the example? Let me give an example. A. Let me write 1, 2, 3. If I write 4 here, that is, I am writing 4 in first row, second column. Then in second row, first column also, I will write A. Same. Then here, if I write 5, that is in first row, third column, then in third row, first column also, I will write 5. Here, if I write 6, here also I will write 6. Then let us see what will be A dash or A transpose. So 145, which is in the first column, 145, I need to write it in the row 145. Then second column 426, I need to write it in the row. Third column elements, which is 563, I will again write it in the third row. Both A and A dash are same. Here A is symmetric. Since A is equal to A transpose. Since both are same, we say it is a symmetric matrix. Next definition is called skew symmetric. Skew symmetric matrix. Definition: a square matrix A, square matrix A, or let me write some other letter. Square matrix B is said to be skew symmetric symmetric skew symmetric if B dash or B transpose is equal to minus B, or if I multiply both sides by minus 1, what will happen is minus B transpose is equal to B. Either this or this. Example B. Again, let me draw a 3 by 3 matrix. Principal diagonal, I will keep it as zeros. Here, if I write 4, here I will write minus 4. If I write 1, here I will write minus 1. If I write 2, here I will write minus 2. Then, what will be B transpose? That will also be 3 by 3. But column elements will become now row elements. Means here I will write 0, minus 4, minus 1. Here second column will become now second row. So 4, 0, minus 2. Third column will become now third row, 1, 2, 0. Now let us check what is minus B. Minus B is multiply minus 1 to all these elements. Multiply minus 1 to all these elements. 0 into minus 1, 0. 4 into minus 1, minus 4. 1 into minus 1, minus 1. This will become 4, 0, minus 2. This will become 1, 2, 0. Let me call this as equation 1. This as equation 2. We may notice now 1 and 2 are the same. We may note 1 is equal to 2. Therefore, I can conclude B is skew symmetric, because that is what is our definition says. B transpose should, if it is equal to minus B, then you say B is a skew symmetric matrix. Skew symmetric matrix. Right. So let us move on to the next type, which is called as submatrix. If A, let us say it is a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If A equal to so and so, and if we delete third row and fourth column, we get a new matrix, say capital B. I'm going to call that new matrix as capital B, which will be B is equal to, what is that? You are removing third row and the fourth column. So what is left now? You will be having 1, 2, 3, 5, 6, 7. Here we say B is a submatrix of A. So that means, what is the definition of submatrix? Any matrix, I can say, that is any matrix which is derived by deleting some rows or and columns. Either you delete rows or columns or both. Derived by deleting some rows or columns and columns is known as a submatrix of the original matrix, Then these are some of the types of matrices. We'll now move on to the properties of matrices, basically of addition of matrices. Addition of matrices. Sorry, matrix, not matrix. It should be plural, matrices. Matrices. Two matrices can be added if and only if. Generally you use IFF. IFF means if and only if. If and only if their order is the same. Means both should be of same order, then only you can able to add. Example, A, B, C, D, E, F. And then let me say B is 1, 2, 3, 4, 5, 6. Both are of same order. Here also you have 2 rows and 3 columns. Here also you have 2 rows and 3 columns. Then I can say then A plus B is A plus B is equal to what you will be doing? You will be doing that, you will be adding the corresponding elements. Means if I choose first row, first column here, I will be choosing first row, first column here. If I choose second row, second column here, I will be choosing second row, second column here, which I will be adding. Means A plus 1, B plus 2, C plus 3, D plus 4, E plus 5, F plus 6. That is the result. Even the order of the resultant matrix also will be the same. That will also be 2 by 3. Next, properties of addition of matrices. First one, A plus B. Whenever I'm writing capital letters, it indicates it is a matrix. Since I wrote positive sign, that means these two are of same order. That is understood. Otherwise, addition is not possible. This is the same as B plus A. What is this law? It is called commutative law. Means matrix addition satisfies commutative law. Let me write that here. Matrix addition satisfies commutative law. Then the second one, A plus B plus C is equal to A plus B plus C, or A plus B plus C. This is nothing but associative law. Matrix addition is associative. Third, A plus O is the same as O plus A is the same as A, where O is nothing but a null matrix. Null matrix of same order as A. Same order as A. Suppose if A plus some matrix X is equal to O, then X should be negative A. Means I'm adding matrix A with some unknown matrix, and if I get a result as a null matrix, then definitely this X should be opposite sign of this matrix A. Means it should be negative A. Then fifth, small k times A plus B will be k times A plus k times B, where small k is a scalar constant, some constant, a scalar constant. Means it can be any number. It can be 2, -3, or it can be square root of 5. It can be anything. It is some constant. And if I add two matrices and then multiply this with that particular scalar constant, it will be the same as individually multiplying the matrices and then adding that. One and the same. Then the sixth one, A plus B is equal to A plus C if and only if B equal to C. Means this expression is possible only if this B and this C, if they are equal. Otherwise, this expression cannot be possible. Next, if A plus C, if it is equal to B plus C, then A should be equal to B. Means if this expression is equal to this, naturally this and this should be the same. A and B should be the same. That is what is our seventh property. So we'll stop this session till this. In case if you find the contents of the video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.